Okay, this lesson is on solving equations by rewriting them in quadratic form. Let's say we have, for instance, the equation x to the fourth minus 13x squared plus 36 equals 0. Now, as it is, that is not a quadratic equation because it has an x to the fourth in it. But what I can do is I can write it in quadratic form. I can make it quadratic by making a substitution. Substitution here. I'm going to introduce the variable u. I could use, some books use z, but I'm going to use u in this case. Let's let u equal x squared right here. Now, if u equals x squared, then I get to replace this x squared with u. If u equals x squared, then u squared would be x squared squared, in other words, x to the fourth. And so this is u squared. So in other words, I can rewrite this equation right here in quadratic form as u squared. Okay, so I'm replacing this x to the fourth with u squared minus 13 times x squared is u plus 36 equals 0. It's now in quadratic form. Okay. We're not going to leave it in terms of u's. At the end, we'll convert back to x's. But at least in this form, I can solve this equation as a quadratic equation. I could either use the quadratic formula, or I could, if it factors, I could solve it by factoring. And this one happens to factor. The two numbers that multiply to a positive 36 but add up to a negative 13 would be minus 9 and minus 4. And so u minus 9 equals 0, or u minus 4 equals 0. U equals 9, or u equals 4. Okay. So I have them solved for u, but remember, that was not the original variable. So at this point, I actually convert back now to x's. Remember that u is equal to x squared, so now I write x squared equals 9. So remember that u equals x squared here. And here x squared would equal 4. I can solve these equations for x by taking the square root of both sides. Let's write it up here. Take the square root of both sides. Remember, don't forget the plus or minus sign. And I get x equals plus or minus 3, or x equals plus or minus 2. And so the equation that I just solved actually has 4 solutions. 4 solutions, plus or minus 2 and plus or minus 3. Or if you want to write them all out separately, though you don't have to, you would have this. 4 solutions to our equation, and they would all work here. Solved. Here's another one very similar to that, to this example. Suppose we need to solve the equation m to the fourth minus 10m squared plus 9 equals 0. Okay, once again, it's not quadratic, but I'm going to put it in quadratic form by making a substitution. Let's let u equal m squared. If we do that, then u squared will be m to the fourth. You just square both sides here, right there, and you get that. Plugging those u's in for the m's, this equation here can be rewritten as u squared minus 10u plus 9 equals 0. And so I now have it in quadratic form. This quadratic can be solved by factoring like the last one, and it factors to u minus 9 and u minus 1. So u minus 9 equals 0, or u minus 1 equals 0, u equals 9, or u equals 1. Okay, remember, we don't stop here at this point. Some students make that mistake of stopping at this stage, but we got to now convert back to m's. u is equal to m squared, so m squared equals 9, or m squared equals 1. I can now solve these by taking the square root of both sides, and I would get here m is going to be plus or minus 3, and here m will be plus or minus 1. And so the four solutions to this equation are -1, +1, -3, and +3. And it's solved. Let's look at another one like this, and then we'll go on to something a little different. Here's another. Solve. 9k to the fourth minus 37k squared plus 4 equals 0. Okay, once again, I'm going to make my substitution. I'm going to let u equal k squared this time, and that way u squared would be k to the fourth. And if I do that, it's very similar to the last two examples that I did. My equation becomes 9u squared minus 37u plus 4 equals 0. Okay, now I think I can solve this by factoring. Let's see if we can do it here. The factors of 9u squared, let's try 9u times u, and then negative factors of positive 4. Let's try let's see here, -1 here and -4 there. That would give me the correct factorization. Setting these equal to 0 and solving, and we get u equals 1/9 or u equals 4. Remember, we don't stop at this stage. We now convert back to the original variable. In this case, u equaled k squared. So k squared equals 1/9 or k squared equals 4. I can now solve these by taking the square root of both sides. Don't forget the plus or minus signs. K equals plus or minus 1/3, or k equals plus or minus 2. And so my four solutions here are -1/3, +1/3, -2, and +2. There are my four solutions. Okay. Let's try one that the solutions tend to be a little trickier on this one. Let's see here. We got the equation now. X to the fourth minus 6x squared plus 3 equals 0. Just like the last three examples, I'm going to let u equal x squared, then u squared will be x to the fourth. So it starts off just like the others, and I can rewrite this equation as u squared minus 6u plus 3 equals 0. Now, what makes this one different is that it does not factor, and so I have to resort to using the quadratic formula to solve it. So I'm going to use the quadratic formula. U equals -b plus or minus the square root of b squared minus 4 times a times c. Divide the whole thing by 2a. b is -6, a is 1, and c is 3. And so I end up with u equals +6 plus or minus the square root of something over 2 here. Under the square root sign, we have a 36 minus a 12, which is 24. The square root of 24 simplifies to 2 square root 6, all over 2 there. Now I can, excuse me, I can factor a 2 out of the numerator. Like that, and that will allow me to reduce right here. These 2's will be gone, and so I now have u equals 3 plus or minus square root 6. Or, in other words, my two solutions so far, 3 minus the square root of 6, 3 plus the square root of 6. But I'm not done, because remember I have to convert back to the original variable u equaled x squared. Now to solve these for x, I have to take the square root of both sides. So actually what we end up with here is a square root within a square root. If I take the square root of both sides here, don't forget the plus or minus sign, I end up with x equals plus or minus the square root of 3 minus square root 6. If I take the square root of both sides on this side, I end up with x equals plus or minus the square root of 3 plus the square root of 6. So this equation does have 4 solutions. If I were to write them all out, I'd have negative square root 3 minus square root 6, positive square root 3 minus square root 6, negative square root 3 plus square root 6, and positive square root 3 plus square root 6. I think I got all the possibilities there. And there's all 4 solutions to this equation. Solve by putting it in quadratic form. All right, let's try one now that doesn't have an x to the 4th power in it. Solve 2 times 4m minus 3 quantity squared plus 7 times 4m minus 3 plus 5 equals 0. Now it's not exactly in quadratic form now, but if I make a substitution, it will be. I'm going to let u this time equal this right here, this 4m minus 3. Let u equal 4m minus 3. Now if I do that, this equation becomes 2u squared plus 7u plus 5 equals 0. It's now a quadratic equation, which I can solve by, this one does factor, so I'm going to solve it by factoring. It factors to u to 2u times u, and then plus 5 and plus 1. Setting each equal to 0, I end up with 2u plus 5 equals 0, or u plus 1 equals 0. This one is u equals negative 5 halves, and this one is u equals negative 1. Now converting back to the original variable, u was equal to 4m minus 3. And so I have this equation and this equation. Solving each one for m now. Add 3 to both sides. 3 plus a negative 5 halves is just a 1 half. So 4m equals 1 half. Multiply both sides by a 4th, and I end up with m equals 1/8. So 1/8 is one solution. If I solve this equation, I end up with 1 half. And so the 2 solutions to my equation here, this one only has 2 solutions, 1/8 and 1 half. Solved. And I believe we have one more example of quadratic form, or 2 more examples, that is. The next one is 2a to the 2/3 minus 11a to the 1/3 plus 12 equals 0. Now for this equation, to put it in quadratic form, I'm going to let u equal this right here, a to the 1/3. Because if u equals a to the 1/3, then u squared will be a to the 2/3. Substituting in here, this equation then will become 2u squared minus 11u plus 12 equals 0. It's now a quadratic equation, which we can solve by factoring. This equation factors to 2u times u, and factors of a positive 12 here. That'll give me the correct middle term. We're going to go with -3 and -4. There we go. So 2u minus 3 equals 0, or u minus 4 equals 0. This one gives me the solution 3/2, and this one gives me a solution of +4. Now remember, we have to convert back to the original variable, and u is equal to a to the 1/3. So a to the 1/3 equals 3/2, or a to the 1/3 equals 4. Remember that a 1/3 power is really a cube root, and so this means the cube root of a equals 3/2, or the cube root of a equals 4. To get rid of a cube root, we cube both sides. So I'm cubing both sides, and I'll get a equals 3/2 cubed, which is 27/8. Cube both sides here, and I end up with a equals 64. And finally, I've got my answers. Two solutions to this equation, 27/8 and a +64. Both solutions will work here. And it's solved. One last example of quadratic form, and that is this one. X plus square root x equals 6. To put this equation in quadratic form, or to turn it into a quadratic equation, the substitution I want to make is let u equal square root x. If u equals the square root of x, then u squared will just be x. If I plug that in, I end up with the x being replaced with u squared. The square root x here will be replaced with u, and it equals 6. It's now quadratic. I just have to move the 6 to the other side, like that. And it's a quadratic equation, which I could solve by factoring in this case. And this one factors to u plus 3, u minus 2. So u will equal -3, or u will equal +2. Okay, it's solved for u. I now convert back to the original variable. Remember, in this case, u is equal to the square root of x. So I got square root x equals -3. And I've got the square root of x equals 2. To get rid of the square root, we have to square both sides. And so if I do that here, I get x equals 9. And if I do that on this side, I get x equals 4. Those are my two possible solutions. Now, whenever you are dealing with square roots in an equation, never trust the answers. You always have to check whenever you have square roots. And if you do happen to check here, x equals 9 is not going to work. If you plug it into the original problem, you get 9 plus square root 9. Does that equal 6? And the answer is no, it doesn't work. So we got to rule out x equals 9. Let's make sure 4 works. 4 plus the square root of 4, is that equal to 6? Yes, it works. It checks. And so the solution to our equation here, it only has one answer. It is x equals 4, and it's solved. And those are several examples of solving equations by putting them in quadratic form.